Hi guys, let's do a couple practice problems from 21.1. It's just a little review of what we did in the last lesson. So you draw one card out of a deck of cards. Event A is going to be drawing an ace and the event B is going to be drawing a heart. So the number of outcomes in A, remember there are 4 aces in a deck of cards, 1 for each suit. So number of outcomes in event A is going to be equal to 4. And then B is drawing a heart. Remember there's 13 of each suit, so number of outcomes in B is 13. So to find the probability of event A, the probability of drawing an ace, there are 4 ways we can draw an ace out of 52 cards total. Okay, so that would be 1/13. Okay, A and B would be drawing both an ace and a heart, and there's only one way to do that because there's only one card, the ace of hearts. So probability of A and B would be equal to 1 out of 52, since there's only one card that satisfies both being an ace and a heart at the same time. And then remember, this little c in the exponent means complement. And an easy way we can find the complement is to do 1 minus the probability of event A occurring, which would be 1 minus 4 out of 52, which would be 48 out of 52, or 12/13. So just a little quick probability review. This lesson, we're going to learn about permutations. So it's a counting method that we use in certain cases. So our objectives today are going to be find the number of permutations and then calculate probabilities involving permutations. So what is a permutation? It's a way you can select objects where the order matters. For example, if I had a class of 30 students and I was picking 1 to be president and 1 to be vice president, the order matters there because I care about which person is in which position. This is different than what we'll do next week, which is called a combination, because combinations, the order is not important. So permutation order matters. So we can find the number of permutations using what we call factorials. And I don't think you guys have been introduced to factorials before, but you may have seen this exclamation point in math. Factorials, actually, it's really easy to calculate. For example, this is just a random example, but 4 factorial, that's how you guys would read that, is just equal to 4 times 3 times 2 times 1. So 4 factorial, 4 times 3 is 12, times 2 is 24, 4 factorial is 24. 5 factorial would be 5 times 4 times 3 times 2 times 1. So you guys get the idea of what a factorial is. We need factorials to calculate permutations. So here's the formula for permutations. The N stands for how many objects we have total, and the R stands for how many objects we are choosing. So I kind of read this N pick R. And the way that we calculate that is N factorial over N minus R factorial. So let's do an example. Move this little video out of the way. There are 7 members in a club, and the club is holding elections for president, vice president, and treasurer. So how many different ways can these 3 positions be filled? So we have 7 people, and we're picking 3 of them to be in an officer position. So plugging that into the formula, on top we're going to have 7 factorial, and on bottom we're going to have 7 minus 3 factorial. That simplifies to be 7 factorial over 4 factorial. And you guys there is a button in your calculator that does this. The permutation button is under Math, and then you scroll over to Probability. It's abbreviated PROB, and then it's option number 2. And in your calculator, it literally says NPR. So you can plug in 7 for N and 3 for R, and then it will automatically calculate this for you. You can also do it by hand by just doing a little simplification. So 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. And on bottom, 4 factorial is 4 times 3 times 2 times 1. So those guys actually cancel on top and bottom. So we're really just left with 7 times 6 times 5, which gives you 210. So there's 210 different ways that from 7 people, we can pick 3 to be president, vice president, and treasurer. Let's do a probability problem using permutations. So a research facility requires a 4-digit security code to gain access. A security code can contain any of the digits 0 through 9, but no digit can be repeated. What's the probability that a scientist is randomly assigned a code using digits 1, 2, 3, and 4 in any order? So we're going to talk about 2 different things here. First, let's talk about our sample space. This is all possible codes we can get with those 10 digits, 0 through 9. So we have 10 digits to pick from, and we're picking 4 of them to be part of our security code. So I'm using my calculator to calculate this. And again, that was to find the function, go to math and then probability, and it's number 2. So math, I'm just doing this in my calculator. So we have 10 digits, we're picking 4 to be part of our code. We have 5,040 codes we can make in our research facility. So now I'm going to switch colors just to kind of keep these ideas separate. Now let's talk about our event. So our event is that we're using digits 1, 2, 3, and 4 in any order. So now we only have 4 numbers to choose from, since our event only has digits 1 through 4, and we're picking 4 of them to be part of our code. So again, I'm using my calculator to calculate this. So I have 4 numbers, I'm picking 4 of them to be part of my code. There's 24 different ways I can arrange numbers 1 through 4 into a 4-digit code. And now we can actually calculate the probability. So I'm going to switch my color again. So this is the probability that we get a code with the digits 1 through 4. And remember from the last time, we do the number of outcomes in our event divided by the number of outcomes in our sample space. So we have 24 outcomes in our event, and we have 5,040 outcomes in our sample space. And when we simplify that, we get 0.005. So there's a 0.5% chance that we get a code with digits 1 through 4 in any order. All right, so sometimes we order objects where we have repetition, okay? We have objects that repeat multiple times. So this is going to reduce the number of overall permutations, and it's going to change your formula a little bit. So say that we have n objects and one object repeats A times, another object repeats B times, and so on. Your formula is going to look like this. You have your total number of objects on top, and then on the bottom you have those repeats. So let's do an example so you guys can see this. How many permutations are there in the letters in the word Arizona? So we're basically looking at how many different ways can we rearrange those letters. But we have a repeat here. A repeats twice, okay? So Arizona has 7 letters total. So 7 factorial, and then since A repeats twice, we're going to divide by 2 factorial. And I'm just going to write this out. 7 times 6 times 5 times 4 times 3 times 2 times 1. And then on bottom, we have 2 factorial, so 2 times 1. So those guys will cancel. We're left with just 7 times 6 times 5 times 4 times 3, which gives us 2,520 different ways we can order those letters. Okay, let's do a little bit harder of one, because the word Mississippi has a ton of repeats. Mississippi, we have the S repeats 4 times, the I repeats 4 times, and then the P's repeat twice. Mississippi has 11 letters total, so on top we're going to have 11 factorial, and on bottom we're going to put our repeats. The S repeats 4 times, the I repeats 4 times, and then the P's repeat twice. So let's kind of simplify this down. We have a super long factorial on top, 11 times 10 times 9 times 8 times 7, 6, 5, 4, times 3 times 2 times 1. And then on bottom, we have 4 times 3 times 2 times 1. That guy will cancel with this guy on top. We have another 4 factorial, so 4 times 3 times 2 times 1. And then we have 2 factorial, 2 times 1. So if we look at this, 3 times 2, that's 6, right? So we can take that 3 times 2 and cancel it with the 6 up top. And then we have 4 times 2. 4 times 2 is 8, so we can cancel that with the 8 on top. And we're left with 11 times 10 times 9 times 8. Oh, sorry, just kidding. We don't have an 8 because we canceled that. So let me erase that really fast. So we have the 11, the 10, the 9, 7, and 5. So in my calculator, I'm just going to do 11 times 10 times 9 times 7 times 5, and we get 34,650 different ways we can arrange the letters of Mississippi. All right, so let's do an example of calculating probability when we have permutations with repetition. So the school jazz band has 4 boys and 4 girls, and they're randomly lined up for a yearbook photo. So let's find the probability of getting an alternating boy-girl arrangement. First, we have to talk about our sample space. How many possible arrangements of these boys and girls do we have? So we have 8 people total, and we do have some repeats, 4 boys and 4 girls. So you also do have a factorial button in your calculator. If you go to math probability, it's number 4. So in my calculator, I'm just going to do 8 factorial divided by 4 factorial times 4 factorial, and I get 70. So 70 ways we can arrange these boys and girls. So now let's talk about our event of getting an alternating boy-girl arrangement. There's 2 ways that can happen. We can start with a boy and then alternate from there. Or we can start with a girl and alternate from there. So 1, 2, 3, 4, 5, 6, there we go. So there's 2 possible outcomes in our event. So the probability of getting an alternating boy-girl arrangement is going to be 2 out of 70, which is about 3%. 3% chance we get an alternating boy-girl arrangement. All right, number 2, let's find the probability of all the boys getting grouped together. So let's just kind of draw this out and see what our event looks like. So all the boys could be together at the front of the line and then the girls at the end, or opposite. And then we can just kind of move the group of boys from there. We can have 1 girl at the front, the 4 boys, and then the last 3 girls, 2 girls at the front, our 4 boys, and then our 2 girls, and then last we can have 3 girls at the front, our 4 boys, and our last girl. So there's 5 different ways we can have all the boys grouped together. So probability of all boys together, there are 5 events or 5 outcomes in our event out of 70 outcomes total, and that gives us about 7%. So there's a 7% chance that just by chance all the boys get grouped together in the yearbook photo. All right, so that's our last example for that one. You guys have a homework assignment on HMH for that, and we'll be back next week with some more probability for you. Let me know if you guys have any questions.